Hello, hi. This is the third lecture. This is the fourth lecture of the course, and this is the first lecture of the second week of this course. So today we are going to talk about abstract data types. So let's just recall what we did last week. Last week we talked about programming in C. In particular, we studied structures, pointers, and function calls. And we saw how one can pass pointers to functions and how to return pointers from functions. We also saw how to create new data types which are of interest, and all these are going to play a very important role in what we do for the rest of the course. In particular, we are going to do a little bit more of sophisticated C programming, very relevant to the focus of this course during this week. In particular, in today's lecture, we are going to talk about abstract data types, and we are going to look at programming methods in the C programming language to implement abstract data types. This is the focus of today's lecture. Again, it's likely to be just a short lecture for the following reason. In today's lecture, I'm not going to show you uh, any C code that has been written. So it's essentially going to be a discussion or a presentation using PowerPoint slides. So in some sense, you can think of this as a theory lecture, a very important background lecture for what's going to come in the remaining lectures during this week. In particular, during this week, we are going to specify different data types and implement different data types. That's the focus for this week. So before I go to my slides, let me also respond to some of the most important things that I have seen on the course forums. Those of you who are attempting to write the program for associated with the Pascal's triangle, um, the the most important thing that you will want to remember is that writing a recursive function to evaluate factorial is dangerous, right? So your program will not work when you submit. Again, that's an exercise for you to figure out why. For example, if you use just the int data type, most likely you will not be able to compute anything more than 17 factorial. Right? So therefore, taking the approach of computing the binomial coefficients using the formula that we study in school for the binomial coefficients involving different factorials is unlikely to work for you. So that is one small piece of advice. The second one is that you get runtime errors when you do not return a proper value from the main function. The submission interface is pedantic, to use the correct word. Uh, it is configured with the assumption that programmers will submit programs where main returns an integer. So therefore your return data type must be appropriately set. So for example, to ensure that you don't get runtime errors, see if the following works. Change your main function to int main and return 0 from there, and check if this will work. Um, Another very important point, and I shouldn't be saying this. I don't think people should be having arguments on the forum. Right? The forum is a very gentle place for you to exchange technical ideas. I request people not to get very emotionally involved with their technical ideas and have arguments on the forum. It makes the whole forum a bit unpleasant. Those of you who want to unsubscribe from the forum, if you look at your Gmail mailbox and the mails that come from the forum, there is an option to unsubscribe right there. So you can unsubscribe, but remember to check what happens on the forum, and remember to look out for the announcements periodically. So yeah, those are a few things that I remember from the experience of last week on the forum. And now let's go to the slides. All right, so this lecture, the fourth one in this whole course, is about abstract data types. And this is a very fundamental concept in the whole study and implementation of different data structures. So you have to pay attention to what the definition of an abstract data type is. So what does an abstract data type actually do? An abstract data type tells you how a data type will work, and this description of how a data type will work will not involve any of the implementation details. And this is extremely important. It's called an abstract data type because you specify the kind of data that you are going to work with, and you're also going to specify what are all the different methods or different functions that will manipulate this data, but you do not specify anything about the implementation, whether you're going to implement it in C or in C++ or Pascal or Java, or whether you're going to implement it using algorithm X or algorithm Y. None of these will be specified when you define an abstract data type. This is a very important concept. What this enables, we will see. Now, what does an abstract data type consist of? The specification of an abstract data type consists of the specification of a collection of data and a set of operations on that data. Typical set of operations that you specify, we will see in a few examples that this is not by no means exhaustive. Depending on the data type that you're designing, you can come up with the appropriate set of operations. So the normal set of operations typically fall into the following classes. You can have a create operation which will create the data type, or rather create the data structure, and you can update the data structure or query the data structure. Observe that we started off by defining a data type, but the operations are on the data structure. So the data type is an abstract specification. Along with the data type, you describe a collection of operations. Now, if you ask the question, where are the operations going to be applied upon? The answer is, the operations will be applied once this data type is instantiated. Let me repeat, the operations will be applied once the data type is instantiated. In other words, when one instance of the data type is created. When you create an instance of the data type, you have created the data structure. Subsequently, you can update the data structure with new pieces of data of the appropriate type. You can query the data structure for the existence of certain data, and so on and so forth. I hope this is clear. Therefore, in this slide so far, we have seen two concepts: the abstract specification, something that you can write on your notebook, right, that consists of description of the collection of data associated with your data type. Apart from describing the data, you will also list the kind of operations that you will perform on that data. The operations typically fall into the categories of creating the data structure, in other words, instantiating the data type, in other words, creating one instance of the data type. Then subsequently you can update the data structure and query the data structure. So let us look at examples of abstract data types that all of us would be familiar with, unless this is the first time you are actually looking at this. So the examples of abstract data types are the most popular ones. An array is an abstract data type. List is an abstract data type. Stack and queue are abstract data types. Tree and binary tree are abstract data types. Set is an abstract data type, and there are many more. So therefore, in this slide, we have seen what an abstract data type is. So this slide essentially was the definition of an abstract data type. So if you ever have to answer this question, right, what is an abstract data type? The second point in this slide gives you the precise operation, the precise definition. An abstract data type is a description of a collection of data associated with the type and a set of operations that may be performed on that data. A description of the set of operations that may be performed on that data. This is what constitutes an abstract data type. Now we come to the central theme of this course, which is a data structure. A data structure, first of all, is an implementation of an abstract data type. It is not just a specification of an abstract data type, it is an implementation of an abstract data type. Okay. So the implementation tells you how the data is organized, and you also describe the operations as C functions. Remember, in the abstract data type, you only say what the functions are by specifying the behavior of the functions. We will definitely see an example. But when an abstract data type is converted, when an abstract data type is implemented, right, in a programming language, and in this case, since we are working with a C programming language, the abstract data type is implemented and you have access to a data structure. Again, let us just visualize what data structures are. You can imagine data structure to be a container. A container is something that holds other data. Container is a very loosely used word. It's not a technical word, right, in this context. For example, arrays are containers. They contain values of a base data type. Stack and queue are also containers. They can be implemented using either arrays and lists, and you can either have a stack of integers, or you can have a stack of, say, characters, or you may even have stack of what are called activation records. I repeat, stack of activation records. Find out what activation records are. We will visit this in a few lectures time. Trees are containers, binary trees are containers, binary search trees are containers. They all contain other pieces of data. Now, each data structure, so if you ask the question, why do we have so many different data structures? The answer to this question is that each data structure is designed carefully and it is optimized for a special class of operations. So here is a pictorial representation of one instance of a data structure. In this case, you will see that we are talking about a list. Right? So a list is essentially a list object, and the list object has 5 elements. It has 5 elements, and you have a pointer to the 5 data elements. The 5 data elements, as you can see, are sitting inside an array of size 11, and the first 5 elements are essentially the elements inside your list object. Okay. So this is essentially what the physical is. Therefore, this is an instance of a data type. Right? So let us just look at what the data type is. The data type consists of a description saying that there is one data item which says what the size is, and there is another data item which is actually an array of size 11, and we maintain our list inside this array of size 11. So therefore, this data structure is an instantiation of the abstract data type where the fields are size and integer valued element, and an array of size 11, and which in this instance stores 5 values. So this is a data structure. Right? I repeat, in this example I have pointed out that this is a data structure obtained by instantiating a particular data type. Of course, this data type was not written in the earlier slides. I have spoken about it. Okay, so now let's move on and get more specific and look at the list abstract data type. So we will now study the list data type and implement the list data structure and so on and so forth in the next lecture. For that, we take the approach that is the focus of this lecture, that first we study the abstract data type without worrying about how we are going to implement. We are not going to worry about which programming language we are going to implement this abstract data type in. We are not going to worry about what algorithms we are going to use. We are just going to describe the data type in an abstract fashion. Right? It's an abstract data type, and the abstract data type is called the list data type. Okay. What does the list abstract data type do? It models a sequence of locations which store arbitrary objects. When I mean arbitrary objects, let us assume that these are objects of a particular basic data type. So for example, let us assume it models a sequence of positions storing integers. Then it becomes a list of integers. Now, the most important thing is that the list data type is a sequence of positions storing arbitrary objects. Remember that it is a sequence of positions and it is not a sequence of values. It's a sequence of indexes, sequence of positions. For every position in the list, there is a well-defined before and after, except for the last position and the first position. So let me just go back and repeat. We are talking about the list abstract data type. The list abstract data type manipulates data. Right? What kind of data? The data is the set of positions storing a collection of objects. And every position has a well-defined before and after, that is a predecessor and successor, except for the first element which does not have a predecessor and the last element which does not have a successor. This is essentially, observe, we've only spoken about the data items. Data items are positions. Now let us look at the appropriate methods that go with the list data type. So let us look at the generic methods. Okay. Size is a method, and we can imagine size will take in an argument which is the list and ask how many elements are there. Now you can think of another method which returns a Boolean value which is the isEmpty method. The argument is a list and the method will return empty or true if the list is empty, and it will return false if the list is not empty. What are the query methods? Right? You can give a location and ask, is this the first location? Similarly, you can give a location called p in this example, the variable p, and you can ask the query whether this is the last location, which means it must not have a predecessor and it must not have a successor if it is a last element. What are the accessor methods? You can ask for the first position and the last position. Right? In other words, first and last will return pointers to the first position and the last position. Then you can ask a question saying that if P is a position that is being given, what is before P? Right? If P is the first element and before P is not defined, you can immediately say that this is an erroneous question to ask. Similarly, if P is the last element, then after P does not have a meaningful value. Otherwise, P has a well-defined before P and a well-defined after P, which is what will be returned. In this slide, I have really not specified the return values. I am speaking them out. Encourage the student to actually write down what the return types are. And I can even say this, return type of before P, right, is a position or an error value. Right? Similarly, after P is also a position or an error value. First and last will take in arguments which is a list, and it will return to you the first position and the last position. Similarly, you can the isFirst and isLast methods return Boolean values, same with isEmpty. Size returns an integer value, it tells you how many elements are in the list. So observe that these are structural methods which ask you questions about the list themselves. Right? Okay. So now the update methods are here. Here you ask, replace the element in P by O. Right? So O is a value. Right? In other words, O is the object that is stored in position P. The replace element method takes two arguments. One is a position P and O is an object O, and replaces the object in position P by the object O. Of course, there is no return value here. The return value can either be a success or a failure depending upon whether P is a well-defined P is a well-defined position or not. Another update method is the swap elements method, which swaps the contents of two locations P and Q. Then there are insert methods which say insert before P the object O. This means that you augment to the list another location, store the value O there, make P the successor, and update the predecessor appropriately and return the modified list. Similarly, insert after, right, is that you insert a new node, you insert a new position after P, right, and in that position store the value O, update the predecessor and successor relationships of all the locations concerned. Insert first O and insert last O are to create positions, make them the first position, store the value O. Similarly, create a position, make it the last position, store the value O. And then the last method is to remove the position P from the list. As you can see that we have completely described all the basic operations that one might want to perform with a list, that is an instance of the list ADT. We have really not spoken about how to implement these methods, and that is going to be the focus of the next lecture when we will discuss a C program which implements all these methods. Now let's move on and look at another data type which we are very comfortable with, which is the array abstract data type. Again, here we do not worry about how the array is implemented and how the indexing of the array happens, etc., etc. These are all the things that we repeatedly use when we write a program involving arrays, but we will not worry about how these are implemented when we discuss the array data type. So let us look at the data that is associated with the array data type. The data consists of a set of pairs. Okay? A pair is an index and a value which is present in that index. So let us just see. If it is a one-dimensional array, clearly the indices are single values, single integers 0 to some value n minus 1. If the array has n elements, right? If the array has space for n elements. On the other hand, if it is a two-dimensional array, then this set gives you an example of the different indices which are possible. Right? 0, 0 is a location in a two-dimensional array. 0, 1 is a location in the two-dimensional array. 0, 2 is the index of a location in a two-dimensional array, so on and so forth. So this is essentially the data that we are working with. Right? So what is the data? The data has an index, and at that index you want to store a certain value. Now let us look at the more generic situation where we want to maintain a j-dimensional array where j is an integer, a positive integer greater than or equal to 1. Right? I repeat, we are going to look at the operations associated with a j-dimensional array. Right? We have seen examples of a one-dimensional array, a two-dimensional array. We are going to talk about a generic j-dimensional array. In particular, we are going to describe the operations. In the description of the operations, A will stand for an array, I is an index, X is an item that you are going to store in the array, J is an integer, size is also an integer. Okay, so now let's look at the first operation. The operation is called create J and a list. Right? Let us just look at this example. Right? Create 2 and a list of 2, 3. The result of executing this operation or performing this operation is that a two-dimensional array is created. Right? The first dimension is of size 2 and the second dimension is of size 3. What do I mean by this? The first dimension is a row. The number of rows is, the first dimension is the rows. There are 2 rows, and the second dimension are the columns, and there are 3 columns here. And the return value is the array. This is exactly what is specified in an abstract way here. Right? So create is a function, create is an operation that returns a j-dimensional array. The size of each of the dimensions is given by a j tuple of integers. This was a 2 tuple of integers, a j tuple of integers, where the kth element tells you the size of the kth dimension. This is something that I forgot to say in the example. The items are undefined. So essentially just the array is created and there are no values which are populated in the array. Right? So this is like a array constructor function. It creates the array and leaves the items in the array unpopulated. Now comes the other methods, which are the update methods, which are retrieve and store. Right? So retrieve method takes the array A as an argument, I as an index, and returns a value which is an item or an error. Right? So if I is a valid index, then you look at the location in the array which is indexed by the value I and return the item associated with that particular index. Otherwise, you return a error message. Okay? So therefore, the return value of this particular function, retrieve, is either a valid item which is present inside the array or an error code. Okay, store ai comma x will, if I is a valid index, the array location indexed by I will contain the value x. Otherwise, you will get an error. I'd like you to recall that the index is just not a single number. It has j coordinates for a j-dimensional array. Though I have written it as a single value I here. Right? Depending on the dimension of the array, this index I will be an appropriate entity. If it's a one-dimensional array, it's a single value. If it's a two-dimensional array, it is a two-tuple indexing into the array, and so on. All right. So what did we do so far? So far we studied, right, what constitutes an abstract data type. Right? So we observed that an abstract data type has two components. You specify what the different kinds of data are, and then you specify a list of methods which are of interest to working with that particular abstract data type. In particular, we saw two examples of data types which we are familiar with. We saw the list data type and the array data type. What are we going to do now? We are going to now look at implementing, we are going to look at the details of implementing abstract data types in the C programming language. That is, in other words, how does one create data structures in the C programming language? We are going to look at the most important practices to become a good C programmer working with sophisticated data structures. That is going to be the focus of the rest of the lecture now. All right. So implementing abstract data types in C. And this is extremely important, right? So let us assume that ADT is the data type that we want to implement in the C programming language. Okay. So the most important thing is that with every abstract data type that you want to create, right, you will have a separate C file along with a set of header files, that is files with the extension .h. Right? So therefore, whenever you want to implement a certain data type which you have designed, there are two things that you will do. You will identify a C file and you will identify a typically about two header files. I'll encourage you to use two header files and we will talk about these two header files. What does the C contain? The C file contain. The C file contains all the implementation details associated with the abstract data type that you are implementing. So for example, the functions, the definition of the functions, and the algorithms that you have implemented inside the functions, all these will be in the C file. Whenever you want to instantiate the implemented data structure, you will include one of the .h files. I will call it ADT.h. Now, why should you include this? Because hash include provides a clean way of using the features of the ADT implementation, right, in the programs that want to use this abstract data type. I repeat, hash include is a way by which your programs that want to use the data type ADT, hash include provides a clean way of accessing the features of this data type by just looking at the .h header file. That is, as a programmer, all that you will do is you will look at what is there inside the .h file, and that will tell you all that you need to know about using the abstract data type. So let me repeat this again. Organizing the relevant information for a programmer in the ADT.h provides a simple interface, right, that enables you, the programmer, to use the features of the abstract data type without worrying about the implementation. Right? The beauty of this whole thing is that if you program in this particular fashion, if somebody changes the implementation, right, without changing the ADT.h, otherwise called the interface, right, your program will still continue to work. Of course, if you want to add more features to the ADT, then the ADT.h should be changed by you or the person who created it. So what is the summary of this slide? If you're going to implement an abstract data type in the C programming language, what you should do is that you identify the methods and the data items in the abstract data type. You put the data items in a .h file. You put the definitions of the methods, right? So in other words, the C functions which are going to implement your different operations, you put them into a C file, and a programmer who wants to use the abstract data type will include the .h file that you've created and go ahead and use the methods which are associated with the abstract data type without worrying about how you have implemented them. Now this has the very nice advantage that if you ever change the implementation of the methods, the program which a programmer has written which uses this abstract data type does not get affected as long as the implementation is correct. Now let's get to the details, right? Please pay attention. So this next couple of slides essentially tells you what you should exactly do. In particular, I tell you even the names of the files that you should really create, and this is a good programming practice. Okay. So let us look at the context. You want to implement an abstract data type. You have written down the definition of the abstract data type on a sheet of paper. You've designed it very carefully. You know what the data items are. You know what the operators are. So what you do is you create this abstract data type by creating 3 different files. What is the first file? I'm going to call this ADTypes.h, standing for abstract data types.h. It's a header file. It contains the type definitions. Remember the type def that we studied in the last week. It contains the type definitions and other constant definitions which are important for describing your data type further. Secondly, remember that since you've already designed the abstract data type, you also have the functions or the operations that you are going to support on the abstract data type. The creating, the operations for construction, the operations for update, the operations for query, all these functions you have already decided. Now you create a second file called ADT interface.h, your abstract data type interface.h. This ADT interface.h contains the prototypes of these functions. Recall from the previous week what the prototype of the function is. So it essentially is a function name, you list the arguments and the return values. It is not the function definition, it is just a function prototype. And you put in the function prototypes in the interface.h. Right? So this is a second header file. Now you come to the .c file. I'm just going to edit something here. Alright. Then in the .c file, which I have named ADT methods.c, you put all the implementations of the functions. In this case, you put in all the function definitions, right? Which function definitions? The functions that you have put in the ADT interface.h. Those functions definitely, and any other internal functions which are necessary for the implementation. I hope this point is clear. Right? These are the functions which are available in the interface. To write these functions down, you may make other function calls. These function calls will be present inside you may write other functions. These functions, along with the functions which are described in the ADT interface.h, will be defined inside the ADT methods.c. Fine. So now you have realized the data type almost completely in the C programming language. Let us go through a little bit more of the details to complete everything. Now the ADT methods.c, which has all the appropriate functions, that is the functions in the interface.h and any other internal functions, right, which are not in interface.h, this .c file will include the abstract data types.h. That is the file that contains the data organization, the appropriate structure definition, and the type names that you created. They will all be there in ADT types.h. Okay? So therefore, ADT methods.c will include ADT types.h. Now you are done, right? So what do you do first? You compile your ADT methods.c and generate not an executable, it is called a .o file, otherwise an object file. On Windows machine, this may come with the extension .obj. Let me add this right in front of you. .o stands for object file, and on machines the extension is .obj. Right? Okay. How do you do this on a Linux machine which is running the GNU-C compiler? This is the command. You type in gcc -c ADT methods.c. It will take you through exactly the compilation that you have done so far, except that it will not create an executable that you can run immediately. It creates a object file, and the name of the object file will be ADT methods.o. For example, if the ADT was list, then the C file would be list methods.c and the output will be list methods.o. So you're almost done, right? You've essentially created, or rather you have implemented your abstract data type, and you've created an object file which has now been compiled and which contains all the important, it contains the whole description, right, of the abstract data type, right, that you can use in some other C program. How do you use the abstract data type that you have implemented? For this, let us imagine that myprog.c is a C program that I am writing, that in which I want to use the abstract data type ADT. What do? I include ADT interface.h. Remember that this has the appropriate interface functions into the data type that we've created. You write down your myprog.c using all these functions and any other functions that you would want internal to this. Now you compile to make an executable. The executable is called myprog. You compile myprog.c along with the ADT methods.o and you give the flag -o. Myprog is the executable that is created. Let us understand what we do. Myprog.c is a program which wants to use this abstract data type that you have designed. Remember that the functions that you can use to access the data items in this abstract data type are the function prototypes are written down in ADT If you go back to the previous slide, that is what we have. ADT contains the prototypes. Okay. So that tells you what are the function calls that you need to make. Right. So using those function calls, you can write your C program and then compile your C program along with your ADT methods.o. Now myprog becomes the executable. Now, very importantly, note that your C program, that is myprog.c, only uses the function prototypes in ADT Therefore, in a manner of speaking, the function definitions which are in ADT methods.o are hidden from the programmer of myprog.c. Even more importantly, even if you have access to ADT methods.c, and if you try to make use of a function internal to it in myprog.c, the compiler will not recognize that function. Right? When you compile myprog.c, if you end up using a method which is defined inside ADT methods.c, observe that the compiler will not recognize this function. Therefore, it forces you to use only the function prototypes that are present in the interface. Right? Now, observe that this is a very good programming practice. Whatever details you must use in the application program are the only ones that are present in the ADT Right? And that is all that a programmer who wants to use the abstract data type will use. Right? So this kind of forces a certain programming discipline. Okay, so let us just summarize what we have done. You design the abstract data type. That is what we did in the first part of today's lecture. Then we went ahead and implemented this. Right? Now, how did we implement it? We created the ADTypes.h and included it in ADT methods.c. We also created an ADT interface.h. Now you compile and generate ADT methods.o. Now include ADT interface.h in myprog.c. You compile myprog.c along with ADT methods.o. And what have you done? You've written a program that uses the implementation of this abstract data type that you had designed at the beginning. This is a very powerful programming technique. Do you recognize it? Think about it. I'm not going to tell you what this programming technique is so that I don't confuse you. You will, as we go towards the tail of the course and as you write more programs using this discipline, you yourself will realize that this is a very powerful programming technique and a very famous programming technique. What are we going to do in the next lectures in this week? We are going to design and implement different abstract data types. So this brings to end today's lecture. Like I said, this has essentially been what you can call a theory lecture. Please go through the video very carefully, right? And this is all that you need to look at the programs that we will write in the next two lectures. Thank you.